Okay, so Van story as to why necessary things can't explain contingent ones didn't work. And he actually agrees with me that it doesn't work. He agrees with me that some of my counterexamples do entail work. But he still thinks it's true that necessary things can't explain contingent ones. He just thinks that's really clear, even if entail is false. And I haven't been able to get clear on exactly why he thinks this. But I can see that there is a kind of pull with thinking that. But I think it's a pull that's mediated by entail. There's something you might wonder, right? So, okay, so granted, maybe in some cases you could have an explanation of something contingent by something necessary, maybe. But what could do it here in the case of BCCF? Well, here's a sort of suggestion that I like. There's a necessary all-powerful being B, such that B necessarily values goods, GI1 and so on. And BCCF necessarily includes these goods. Okay, so this is meant to be some kind of a subset of all the goods there are. Not all the goods there are in fact included in the BCCF. For example, a wonderful good is utter painlessness. That's not a good that's included in the BCCF. Yeah.
What do you mean by BCCF necessarily includes? I would have thought anything included in BCCF was...
Oh, BCCF is some proposition. So it's some really long proposition. Some proposition like Napoleon was vanquished at Waterloo, and there are electrons, and string theory is true, and blah, 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 and all the other contingent stuff that's true.
So I thought BCCF was necessarily, was able to pick out a single unique metaphysically possible world. But you're saying that maybe other worlds can have BCCF plus other factors?
No. So I'm just saying BCCF necessarily includes these goods, namely any world that includes in which BCCF is true exemplifies these goods. There's only one world.
There's only one world. So
there's only one that exemplifies BCCF.
Not doing any work. It would mean the same thing if you got rid of the necessarily.
Yeah, in this case. I mean, or it would follow. But I want to emphasize that the explanation I'm giving is a necessary one. Okay. That's why I put it in. So I can abbreviate it, right? So because B values these goods in the BCCF, B creates the BCCF. You might wonder, what if an alternate world described by a BCCF prime was actualized? Well, that would have some other explanation of a similar sort. There would be some other subset of the goods, and that would explain that. This is actually sort of a toy story about the world. I think it's pretty. I actually am inclined to think it's pretty close to the truth. Different God for each world that God could create, there are some goods that world uniquely exemplifies for the sake of which He creates it. PSR doesn't require contrastive explanations, but this is contrasted with my little funny sort of contrastive sense. For a BCCF prime were true in place of BCCF, and this wouldn't explain it. It would be true, but it wouldn't explain it. Instead, what it would explain is this. And this kind of thought extends to show how free choices might be explained. So where were we? We had this little argument with the conclusion that doesn't follow logically, but only probably. And I gave a few reasons to think that the PSR is true. If the PSR is true, then the big fact has an explanation. And I gave some reasons not to think that it's false. So if PSR is true, so is explanation. If PSR is false, then I think some replacement for the PSR is true. Seems like the kind of work we need the PSR to do should be done by some principle. If we can come up with a reasonable candidate for an explanation, here's one possible replacement. If we can come up with a reasonable candidate for an explanation of a contingent truth P, then probably P has an explanation. So if there's a reasonable candidate, of course, people are going to differ on what counts as a reasonable candidate. But that might be a replacement. Another possible replacement would be if a contingent truth P could have an explanation, and it does. If it's the sort of thing that could have an explanation, and it does. Particular Humean laws, notice, satisfy this one. Because a particular Humean law, as a universally quantified proposition, stuff moves like, it behaves like that, could have an explanation. Even if it's fundamental in our world, in some other world it might not be fundamental. And so it could have an explanation. And so this principle is actually pretty strong. It would imply that those fundamental Humean laws actually have an explanation in our world. So it's a strong principle. Though on the face of it, it doesn't sound very strong. Or another replacement, we should assume a truth has an explanation until it's shown otherwise. I think each of these could be used in place of the explanation premise in the argument. The argument would be weakened. Here I would have to show we can't come up with a reasonable candidate. In fact, I think the theistic one I gave would be such an example. Here we would have to show that it could have an explanation. That might take a little bit more work. Here I would have to say that it hasn't been shown otherwise, which seems right. So even if one doesn't think the PSR is true, something like this argument could still perhaps be run on the basis of the PSR. And there is a little bit of a literature on replacements for the PSR. Various versions, weakened and restricted and otherwise. And some of those, and there's questions about which of these could be used to run a cosmological argument, which couldn't be. Yeah.
Just a brief comment. The sort of, what you say about what would happen in the case of union laws, I think, is perfectly logically coherent. But maybe it's worth pointing out that the union point of view sort of naturally carries with it a conception of what you're doing when you explain things, which has to do with, which has to do with fitting, which has to do with showing the person who asked for an explanation how the particular fact that they're asking about sort of fits into what you call the big fact.
Yeah.
Okay. And that's how the activity of explaining things is conceived within Jungian points of view. So, of course, what you're saying is logically compatible with what people say.
But not with their motives.
Yeah, not with the picture of explanation that they have in their heads. Right.
Yeah.
Right. That is, on the picture they have in their heads, explanation is quite explicitly something that doesn't make much sense undertaken with respect to what you're calling big fact.
Yeah. Would that hold just for the Humean's conception of scientific explanation, or are you saying just generally?
No. I take it the conception there is that the paradigmatic form of explanation is scientific explanation, and that's what holds for scientific explanation.
Okay. I mean, we can talk about this. I mean, I have some stuff that's not very original to say on Humean pictures, and we can talk about that maybe next time.
So, another quick question now. Sorry, just real fast.
Yeah.
So the proposition, so suppose alpha explains the big conjunctive contingent fact. The proposition that alpha explains the big conjunctive contingent fact is going to be itself contingent, right?
That's a good point. Yeah, I actually think it might be explained by alpha. We can get into technical details if you like, but I actually think there's no problem with that. I think claims about what explains what are beyond. I mean, the human will also say something like that. What explains why it is that this regularity explains this event? Well, it's some necessary truths about the nature of explanation, plus the fact that this regularity holds and is and is in the best system.
Right.
So you can actually do that. Okay, where are we now? Well, so we now need to move on to the second premise, and I'm going to be pretty quick here, I hope. Here's why is the best explanation creation by a purpose being, given that there is an explanation. I think the better explanations of the Big Bang should explain fine-tuning, if there is such a thing. And I'm not a physicist, maybe it'll turn out that there's some neat theories where there isn't any fine-tuning, but let's just suppose there is. Right, the sort of talk was billed as implications of cosmology. Let's just suppose that we're going to get some kind of fine-tuning of some parameters that's needed for life or something like that. So the better explanation of the big fact should also explain fine-tuning. I mean, you can have an explanation that doesn't explain that leaves you really puzzled about weird features, right? I mean, here's an explanation of why the rocks on a beach spell out hello. Well, there was an avalanche, and the rocks moved randomly into those positions. That could be true. That's unlikely. But it's not a very good explanation of the hello pattern. But it might be the best one we have. It might even be the true one. But if we have a better one, we should go for it. So what are some options? Well, one option is that since Hume, a sort of infinite regress story. Another option, maybe necessarily they're nice laws. And by nice, I mean they're mathematically elegant and they don't require any kind of fine-tuning. All the constants are pi, where pi is appropriate. 2, where numbers like 2 are appropriate. You don't want 2 where we're talking about angles, for instance. Right? 2 radians is very unnatural. Maybe a multiverse. That certainly might help with the fine-tuning plan. And then there are supernatural options. Optimalism. Everything is for the best. A lovely view. And self-explaining too. For wouldn't it be for the best if everything were for the best? As Nick Rescher says. Non-theistic supernatural options. And theism. Creation by a perfect being. So there may be others. Right? I haven't divided up logical space. I've just given what seem like prominent options. And I'll say briefly a few things about each one. Yeah.
I just want some clarification on the structure of the argument. So, at the beginning of the talk, you said that explanations are factive.
Yeah.
So, now I'm a little confused about what the role of creation by a perfect being a better explanation.
Okay, that's a very good point. Yeah, so yeah, I have been going back and forth. It's very hard not to, right? So I think explanations are factive. As a matter of fact, it's false to say that a conspiracy theory explains why Obama is thought to have had the majority of the votes in the Electoral College. Or a conspiracy is the explanation. That's false. But it is sort of true that where there's such and such a conspiracy theory, it would explain it, and would explain it very well. So when I say that sometimes I have been slipping into using the word explanation when I mean putative explanation. And some of those are better than others. And that prescinds from their truth. But I'm hoping that the goodness in some ways, evidence for the truth, and they're bad, they're not less goodness as evidence against the truth.
Can you give an example of a non-theistic supernatural option?
Yeah. Optimalism and optimalism actually was, so I guess it should be non-theistic, non-optimalist ones. I don't know, actually. We'll get to it. It was late at night when I was writing that part. I don't remember which ones I came up with. I didn't think any of them were very good.
Are you talking about something like we live in the Matrix?
Polytheism, maybe, or something.
We live in the Matrix, but the Matrix is run by something that's not theistic.
That's another one.
Well,
That
no,
wasn't on my
that's
list.
a fixed
Yeah.
Depends on what it's run by.
Right.
If it's run by a committee of deities.
Right.
Or we were created by supernatural aliens.
Yeah, or Descartes' demon created us.
John Leslie has this, it was, the ultimate explanation is just, it's morally good.
Yeah, that's optimism.
Okay.
Yeah, so let's see. So the regress story, I've got lots to say on this, but I won't. So this comes from Hume, who says, a very plausible thing, right? Did I show you the particular cause of each individual in a collection of 20 particles of matter? I should think it very unreasonable. should you afterwards ask, what is the cause of the whole 20? That is sufficiently explaining the cause of the part. And he doesn't use this, you could try to use this, you could try to use this kind of line of thought to defend explanation of Humean laws, but he isn't. What he's doing this is in support of the idea that we could have a complete explanation of everything if we had an infinite regress. This thing is caused by that, that is caused by that, that is caused by that, and so on ad infinitum. And he says, that's an explanation, but why? Well, look, each of the items is caused. And implicitly, he's assuming that causation implies explanation. Each of the items, which I agree with him on, each of these items is caused, each of these items is explained, so they're all explained. I think he's certainly right in the case of 20 items, but not in the case of infinity. Infinite regresses leave unanswered, I think, the question of why the whole regress is as it is. The difference is that, barring circular explanation, if I have 20 particles of matter, as Hume supposes, if each one has an explanation, at least one of these explanations will involve something other than these 20 particles of matter. Otherwise, one of the explanations will be circular. With infinitely many cases, you can keep within while still giving each one an explanation. But I think you still don't have an explanation of the whole, unless there's something outside the infinite regress. Each step in the regress shifts the bump in the carpet. Besides that, there's a fun story Richard Gill once gave about infinite, which he uses to initially motivate the intuition that there's something fishy about infinite regresses. He says when he was a kid, he would go into the movie theater and each of the kids would go like this, pointing to who gets the bill. Imagine everybody is like that. There's something wrong, right? It's like wondering, it's like the old explanation of why it is that the Earth doesn't fall down. It's on a tortoise, and the tortoise is on another, and all the way down. That just makes it more puzzling. The poem's even heavier. I remember, I have never been able to track this down again. I remember reading an excerpt from one of the Socratics, who wonders about this deep problem of why the Earth doesn't fall down. Deep problem. Everything else falls down, as you can see. Everything else that has Earth in it, that's earthy, falls down. So the Earth should too. Why doesn't it? Well, this pre-Socratic says, it's on a long pillar, a very long pillar, whose bottom is shrouded in mist. Right, so he saw the point that adding more pillars wouldn't help. You need to cover up that gap. With mist there. And so whether you click mist there or an infinite regress of pillars, it doesn't do the job. And I think that means that actually somebody who thinks that there was in fact an infinite regress and that there's nothing outside the regress should just honestly say, there is no explanation. They shouldn't say, yeah, there is one. This is an explanation. They just wants to say, I'm sorry, I just don't believe the PSR. Here's one line of thought against the Hume principle that if you explain every item in this set, you explain the whole thing. Let T1 be 5 minutes ago, and let S be a set of states of the universe at all times bigger than T1. And suppose, something fairly classical where you have well-defined terms and all that. Each member of S is explained by another member of S, right? You look at any time greater than T1, there's some time between that and T1, which explains what happens at the later one. And you want to know what happens, why the state at T2 is as it is. Well, I choose some state that's halfway between T1 and T2, and that explains it. And that state is also in S. Oh, so each member of S is explained by another member. And by Hume's principle, S is self-explanatory. We've done all the explaining that needs to be done. It's all done with an S. So we don't need to say what happened earlier than 5 minutes ago to explain the world from 5 minutes ago, well, later than 5 minutes ago. But surely we do. I mean, surely we don't. There's tons of stuff that we haven't we just have not explained all of S if we haven't said what happened at T1.
Yeah.
So, what this argument shows, I think, is that, look, we have two plausible assumptions that we make about explanation. One is that nothing explains itself, and another is that if we sufficiently explain each member of a conjunction, we've thereby explained the conjunction, right? What the argument shows is that we can't hold both of those if we think there are infinite conjunctions. But why should we favor dropping the one that says if we've explained every member of a conjunction, then we've explained the conjunction, instead of dropping the one that says nothing can explain itself?
Because it does not seem right to say that you can explain everything from T1 on without mentioning what happens at T1. And I don't mean T1 to be any special time, right? I said it's 5 minutes ago. It's not like the time of the Big Bang or anything. It's just an perfectly ordinary time with, no more singularities than are ordinary. And surely, I don't have an explanation there.
I'm confused. Sorry, can you go through the second, maybe I missed the second.
So
the argument goes from the fact that S is self-explanatory to saying that we don't have to mention anything before T1.
Well,
So
yeah,
that's why
if
we
S
have
is
to
self-explanatory, then it's got a complete then it explains itself. And so we have an explanation of S without mentioning what happens at T1. All right, so we've got, suppose it's just one particle, right? And it's got some kind, maybe it's, and S then contains all of its, let's say its classical positions and momenta at all times greater than T1. That doesn't explain the whole set. You've got to know what's happened at T1 or have some other story. But just by itself, this series doesn't explain itself.
Yeah, you go.
Yeah.
Seems like there's another axiom in going from, we can explain each element in the set to the whole set at once. That we have to explain the whole set at once.
But it's not that we have to. I mean, Hume doesn't actually think we have to. I mean, this is what he's doing in the dialogues is he's coming up with various refutations of the cosmological argument. One of them is this. He says, if you want an explanation, you can have one. But he doesn't actually think you have to have one. He's perfectly fine with saying things can come into existence for no cause at all. But he just wants to say, look, you non-Humeans, even on your grounds where you think everything has an explanation, you have no reason to balk at my Humean story because an infinite regress provides you with one. And I think he's wrong. Infinite regress doesn't. And I think the problem is that you can't generalize from the case of 20 particles to the case to an infinite regress. He does, because there's a crucial disanalogy in the case. In the finite case, one of the causes goes outside the set. In the infinite case, none of them, it may be that none of them do. I actually think that you could have a case where, I'm not here objecting to infinite regresses per se. I'm just saying they are not explained by themselves. Maybe there's some being outside the regress that explains. Maybe the laws explain the whole regress. But the regress doesn't do the job. Another option, I have very little to say on this, necessarily the laws are nice. They are fine-tuned and elegant and beautiful. We don't have a causal candidate for such nice laws. I think even if we did, it wouldn't be plausible that the laws are metaphysically necessary. I think that the other laws would be metaphysically impossible. And I think that would actually give us more to explain. Why are they so neat and elegant? I mean, even if you think that we should expect laws that are briefer and more compact, because you've got some kind of a priori measure on laws that favors brevity, something like some of the complexity measures people come up with. Even so, there are going to be plenty of other laws of at least comparable levels of complexity that are not fine-tuned. Now here's a super brief law that's not fine-tuned for life. There does not exist anything. That's simpler than any law anybody's going to come up with any interest in. Here's another option, multiverse. Got a neat explanation of fine-tuning of constants and initial conditions for life because you've got enough tries added, some of those tries are going to work out correctly. And by golly, we're not going to observe the failures because we're only, observers only exist at the successes. There's no explanation of the existence of the multiverse as such and the fundamental constraints, if any, on it, if that's the whole story. I mean, it might be a part of the story. It might be that there's a multiverse and then there's some further supernaturalistic, say, explanation of the multiverse. There are a number of people who think that sort of thing. But I don't think it's going to be a full story. You need an explanation of the existence of the multiverse and any fundamental constraints on it, and any laws that hold throughout the multiverse. Now maybe you can try to ratchet it up. You say, well, but it's necessary that there is such a multiverse. And here I want to distinguish three kinds of multiverses. One kind is the physics kind. You know, inflation, string stuff, sort of arise. I guess the general formulation sort of arises out of physical theorizing, and all the island universes within it share some core laws. A fair amount of core laws. Another option is metaphysics ones, motivated by sort of deep metaphysical thinking, even if done by physicists. David Lewis or Max Tegmark are examples of that. And these are really big multiverses. And I mean, Lewis won't like the term multiverse in this case, but basically, right, every way that something could be is realized. Every mathematical structure has a concrete realizer. So these are really big. There are no constraints except those of logic, maybe metaphysical possibility or something, but there are no contingent constraints of any sort. And the third option is supernaturalistic multiverses. And let's see, where are they? And John Leslie, Nick Rescher, Donald Turner, and Klaus Craig have defended these, and some others. We can do a further subdivision if we want. We can subdivide the multiverses into the finite and the infinite ones. This subdivision cuts across these. All of these are infinite multiverse theories, and some of these are, and some of these are not. Some of these have only 10 to the 500, a very small number, compared to infinite. Yeah.
In that situation, there might be a finite number of solutions, but many people still talk about an infinite number of realizations of those finite number of solutions, which need to be repeated an infinite number of times.
That could be. So so the finite ones are going to be a subset of the physics ones, and yeah, that's right. The ones with a finite number of solutions which solve the multiverse. Even the ones with one solution, you could have a multiverse story. Let's just repeat it. Okay. It's implausible, I think, that it'd be necessary that there be a finite multiverse, especially that there be a finite multiverse of a particular size. That's just an intuition on that. Fine-tuning would require fine-tuning of laws. Somehow it seems impossible there'd be only a finite set of options. That's just an intuition. You might not share it. Infinite ones face an in-principle, insoluble measure problem. I promise, I'm not promising because time is short. I may say something. If not, take the things that have been said earlier by people other than me. But if not, maybe I'll have some. I might have something to add to that. Optimalism. Two varieties. There are theistic optimalists, Leibniz, Donald Turner, Klaus Craig. They think God and his goodness couldn't but create the best possible option. Some will go even as far as if they were a tie, God just wouldn't do anything. Leibniz says that. Just sort of metaphysical paralysis would set in. So that's one kind of optimalism. And that kind isn't going to disturb the cosmological argument at all. That kind embraces theism, but maybe not of a completely orthodox variety, because there's only one The other variety is principle based. We think, just like you might think that this is, just like non-humans may think there are governing laws, these guys think there are governing principles. And these principles not only govern stuff that's already there, but they can make stuff happen. And the principle that Leslie and Rescher suppose is everything must be for the best. Only I think the principled ones are fundamentally optimalistic, because on a theistically based one, so what's fundamental is the theism, and then optimalism follows. Standard objection, does this look like the best world? Read Candida, stuff like that. Rescher's answer to that is you're looking at the wrong things. Sure, there's a lot of misery and all that, but that's not the relevant values for the optimizing of the world. Sure, they count for something, but look at the elegance of the laws. That's what's really matters. Leslie's got a different answer, which is, Leslie's got some kind of a multiverse. And if you've got a multiverse, you could say this is the best world even though it doesn't look like it, because maybe the best world is the one that includes all the options that are good enough. And then all you need is what's around it is good enough. I mean, Donald Turner actually initially introduced the multiverse, his theistic multiverse, to solve the problem of evil. He said, look, sure, there's all this terrible evil around us. If God was creating only one world, we wouldn't expect him to create this one. But if he's creating infinitely many, he might create all the ones which are on balance better than existing than non-existing. And by golly, ours, that's not a very high standard. It's not that hard to believe that ours world, especially given that we observe only such a small portion of it, it's not that hard to believe that our world meets that standard. And so he's created all of them. So if you've got a multiverse in the picture, you can get a nice answer to objection 1. If you don't, you've got to do theodicies or have an odd value system like this. There's another worry I have, which is I don't think there is a sense of talking of the best world, because I think there's no total ordering on values. I think there are values that are incomparable. Simplicity and diversity, mercy and justice, elegance of laws and lack of suffering. Maybe we've got elegance of law, but not lack of suffering. Being a physicist and being a musician. In each case, you can't say one is better than the other. And the lack of such ordering of values, I mean, this is also very quick, makes it to me implausible to think that there is a best world. We have to optimize every value. Or at least, in any case, there's an argument by Rescher that if you've got principle-based optimalism, you get theism again anyway. Because isn't it for the best that there be a perfect being? So Rescher turns Leibniz on his head. So Leibniz thought, because there's a God, everything's for the best. Rescher thinks everything's for the best, so there is a God. So here's what I think is the right theory that I'm going to defend, which is the theistic story. Let me give a little background of how I think theory choice is going. I think we should try to maximize the simplicity of the unexplained hypotheses of a theory. For instance, you might think a simpler theory is better, and here's how you count simplicity: just count the number of objects that exist on the theory. That seems bad. On that theory, we should prefer the theory that the human race goes extinct tomorrow to the theory that the human race goes extinct in 100 years. Because there are more objects on the theory that it goes extinct in 100 years, and hence it's more complicated. We don't want that. When we count the simplicity of the theory, we should count the simplicity of the unexplained hypotheses in the theory, or the ones unexplained by that theory, of the fundamental causes. And so you look at evolution, isn't it lovely? All of this stuff, all of this vast biological complexity is explained by one initial organism and then a bunch of evolutionary principles. But there's a vast, there's a sense in which a Darwin system has multiplied the complexity if all you're doing is counting entities.
certainly multiply the complexity of the biological world over a hypothesis that is 10,000 years old. Way more organisms. But that's okay, because it's only the unexplained ones that count. And for evolutionary theory as such, it's only the first organism that's unexplained. It might have an explanation outside of evolutionary theory, but one in evolutionary one, probably. So this is my Claudia Trendy-Wordy's little principle. Theism has a very simple hypothesis that there's a perfect being. There are no free parameters. A perfect being exists of necessity, is the ground of all being, one of the perfections. The PSR, because I've restricted it to necessary things, doesn't require an explanation of a necessary being. Maybe there's some kind of deep ontological explanation. I don't know. But the PSR doesn't require it. A perfect being knows what possible worlds are more valuable and in what way they're more valuable, and it acts on the values to the extent that the values are morally and rationally compelling. I think this is just a logical consequence of the notion of a perfect being. It's one of the moral perfections, is that there's a moral perfection that you act on the values that you have, and there's an epistemic perfection that you know what the true values are. This, of course, requires a realism about values, which is controversial. But hey, it explains stuff in ethics. Yeah.
So there are some who argue that the perfect being would be a lot more complex than you're assuming. But what about assuming that instead of perfect being, there is a perfect something that's not a being? Being itself seems very complex.
What do you mean?
Does that give you the same?
Being is just entity, right? I mean, there's a perfect being means there exists an X such that X has every perfection. I happen to think that one of the perfections is intelligence. And that's one that helps with the fine-tuning aspect. You might have a different theory about perfections, in which case we could agree that there's a perfect being, but disagree on whether there is a God. Because maybe you think that being a person, being intelligent, being conscious are not perfections, in which case you could think there's a perfect being, and I could think there's a perfect being, but we could disagree on whether there's a God, because I think being intelligent is a perfection. But yeah, so I am assuming in my story, part of my story, is that I think it's true that in fact that intelligence and things like that are perfections. But it's very good to point out that that could be resisted. I mean, in this philosophy, people, right, everything gets resisted. And what happens can happen, so therefore everything can be resisted.
Well, just a very straightforward, question. Why does God have to be a being?
What do you mean by a being?
Just like what you said, an intelligent
I don't
like
understand
us.
what it would be for something not to be a being. For something.
The term entity being used here is like the broadest ontological category.
It's just
something with positive ontological status.
something that's in the scope of doesn't quantify or something like that.
But why does God have to be an intelligent being
Okay, an intelligent one.
like us, but much, much smarter?
Well, that's a fair question.
That's what I'm asking.
And what I'm saying is that I think, as a matter of fact, intelligence is a perfection. And so a perfect being is one that has all perfections. That's what I mean by a perfect being. And so you could have sort of somewhat perfect beings that have a lot of perfections but not intelligence. There you've got free parameters. Which perfections you include and which ones you don't. The one that has them all doesn't have those free parameters.
The thing I'm resisting is the personhood aspect. Why do we expect God to be a person like us?
Well, I mean, like us is
That's
yes
all we
and
know.
no. I mean, everything is like everything else. But God is also utterly unlike anything else. Yeah.
Some of the perfections might be incompatible with one another.
Yeah.
And that could lead, there might still then be a greatest possible combination of perfections.
There might be.
But it also might be that there's, there's different combinations that would either result in equally good beings or beings that are good in their own way, but for your sort of incomparability of values reasons, they might not be.
Yeah, you could, that could be the case. You'd have a more complicated theory then. So I prefer this one. If you had that one, then I think the way I would run this argument, if that turned out to be right, would be along the Swinburne line and single out central perfections. In his case, he thinks it's something like omnipotence and omniscience. You single those out and say, okay, we've got some, it's a more complicated theory. We're supposing there's a being that has these two things. It's still fairly simple, but it's less good. And I'm happy with that. I'm just giving what I think is the simplest version. If it turns out to be untenable, then one trust me.
I'm sorry, I missed the two.
Omniscience and omnipotence. So Swinburne thinks that if you've got omniscience and omnipotence, you get goodness from that, because a being that can do everything would have and that knows what the right thing to do is, would have never a reason to do the wrong thing. That does all the explaining work in Swinburne's system.
So, do you need to make a difference between, when you're thinking whether a hypothesis is simple, between whether the hypothesis has some sort of complicated corollary or whether the complexity is actually smuggled inside the hypothesis?
Well,
So, quick example, so, it's 1959, you want to know the probability of a hypothesis that man walks on the moon within the next 20 years. You could say, well, that's very simple, you just need to put someone on the moon and have them take a step. That's a simple hypothesis. Or you might say, well, think of all the things you need to do to get a man on the moon, or build rockets and NASA and all of that sort of thing. So actually, you've smuggled a lot of complexity inside the hypothesis.
I don't think that's a case where you've smuggled in a lot of complexity in the hypothesis. I think it's a case where you've got a different theoretical defect. Namely, it's one where it's pretty clear that that the hypothesis itself is the sort of thing that's in need of further explanation, and that those further explanations would have to be very complex.
So
In the case of a necessary being, maybe you don't have the same. I do want to, though, say what I said earlier about deep questions tomorrow. Oh, it's a shallow one.
Actually, I hope that it's a simple question. I'm just asking if this is related to Andy's question, I guess, maybe not. Why is this perfect being necessarily isolated from the world? So I think of now, do you exclude by definition pan-theistic and pantheistic views? Because I don't see why they should be more complicated than a perfect being, theistic view where God is isolated from the world or before the world or whatever.
Yeah, pantheism comes in two versions. There's deflationary pantheism, which says this world, that's all God is. There's nothing more to God than this world. But there's also kind of spiritual pantheism, which says this world around us, it is God. But when you just look at the sort of stuff that science does, that doesn't really tell you what this world is like. It's got this deep spiritual reality to it that goes over and beyond it. The first kind of pantheism, I think, is not going to help here. That's just not a plausible candidate for a perfect being. The second, I can see a case being made. That there's a sort of depth and beyond everything and all that. I'm inclined to think that a perfect being would not. It's hard enough to say that a perfect being would allow the horrendous evils we have. That a perfect being would have them as part of it seems even harder.
Yes, but I'm sorry, just one more remark, maybe we can discuss it tomorrow. There are problems like the freedom of God, things like this. So this hypothesis could become very complicated if you try to infer from it something like an omnipotent being is free to decide what he needs to do or not. And maybe if he's not isolated from what he's doing, is a more simple hypothesis. I just want to point out that I don't think that this classical perfect being is that simple, or you can make it consistent or more consistent than
Well, I mean,
atheistic view, but maybe we discuss this.
well, yeah, I mean, maybe the theory isn't simple, but maybe the theory is simple, but it has problems, right? And that certainly can happen. Easy to come up with simple theories that have problems. But I still say that's a simple theory. There doesn't exist anything. It's a very simple theory. It's got lots of problems. Yeah, maybe, yeah.
So I think I'd like you to say a little bit more about thinking of free parameters. Because when we think of like the free parameters of the standard model, we don't think that they like don't have values at our world or something like that. We just think that they're not fixed by the way the math of the theory goes. So similarly, I would think that the way your theory looks, the right values are free parameters because they're not fixed by sort of the structure of the theory, which is there's a being that sees the true values of an axiom. Right? There might be facts about what the values are, but it looks like
But
from the point of view of your theory, they're free parameters.
They're necessary facts though, about what the values are. And
I
they're
mean,
not.
if I'm a Kripkean about natural kinds, I'm going to think that they're
Yeah.
necessary facts about
Yeah.
the parameters of the physical theory.
That's a
right?
good
Like the
point.
density electron.
That's a good point.
And I still think that those are free parameters.
Yeah, so how valuable is justice? How valuable? That's interesting.
Yeah. Yeah, so
Yeah, so here's what, I guess I can say this. Thump this to the table and say moral realism is true. There in fact are such values, right? There in fact are such values. Some of these are in fact more valuable than others. And all the explanations are good. None of the alternatives to the theistic one explain what these values are, nor does the theistic one. So they're all on par with respect to that amount of complexity in the world. None of them explain the moral sphere of the world. And none of them, I mean, you could have a theistic explanation. Divine command theories try to do that. But, yeah, I should move on. We go tomorrow. Then I say, the value of intelligent observers is highly morally and rationally compelling. So is the value of simple and elegant laws of nature. Those aren't the only values. There's more than one way to realize them. So not everything is a necessity. I think we get a very fundamental and elegant explanation. It's very fundamental. It explains in terms of all the contingent stuff and in terms of necessary stuff. It's elegant, and we can put it very briefly. Maybe you don't agree that it's elegant. But it's at the expense of two defects, right? It's very low on detail. And it's low on predictivity on its own. If you add some stuff from real religions, you get more predictivity. I kind of want to compare it to evolution in the time of Darwin, which is a good theory. But at that time, at least, it was low on predictivity and fairly low on detail. I want to quickly answer two quick objections, too quickly. And this kind of connects with some of the remarks made. We don't have anything like a complete axiomatization of the perfect being, so it's not on par with hypotheses from science, like multiverse ones. And I say, sure we do. Here's one. X is a perfect being if and only for every property P that's a perfection, X is P. I say, really? Is that what you mean by a complete axiomatization? I mean, surely, look, you've got no complete axiomatization of a perfection. Well, and like this, I want to say actually, yeah, but look, we don't have anything like complete axiomatization of any theory of physics, right? Suppose some theory of physics supposes a Hilbert space. Hilbert spaces live in universes of sets. There isn't, and there cannot be, according to Gödel, a complete, consistent axiomatization of a universe of sets. We're never going to get complete axiomatizations. So it's only a matter of degree. Now you might still think, yeah, but there's an important difference in degree that's harmful to this theory. Another problem, evil, right? I have nothing, I'm not going to answer the problem of evil grouse. The Odyssey, which isn't an answer. It's an invocation, not an answer. I do think recalcitrant cases present, of evil present an anomaly, but we should expect anomalies in any wide-ranging theory. My colleague and I have a paper where we argue for this. And we argue that the scientists shouldn't be bothered by anomalies in certain contexts, and that theists shouldn't be bothered by anomalies in certain similar contexts. But this is the big, this is, I think, the really big objection to the theory.
What about the notion that modesty is a perfection and therefore being too perfect is bad, and so you should have some
Being perfect and modest about it is great. I like that.
That's all.
So that goes with Dean's worry that the perfections may be incompatible. Good. I like that. Non-theistic supernaturalism, I'm not going to say too much. I think polytheism, finite broad theories have lots of free parameters, just how finite they are, just which of the deities exist. Pantheism doesn't explain the universe, unless it makes it necessary. It doesn't seem plausible. Pantheism, actually, I think, is either an orthodox or a heterodox theism. We can talk about that, but I've never seen a distinction. Pantheism seems to be something like God is in everything. So, yeah, the orthodox theism says God is everywhere. So, here, where this is, God is. So, he seems in some sense to be in the space occupied by this, so in some sense in this. Seems perfectly orthodox. There are some unorthodox ways to understand it, but it's at least some kind of a theism. So it's not non-theism. So we have something like this argument. Now, I don't know how much I'll have of the other stuff, but I do want to start a little bit and maybe just put be in the bonnet of some people thinking about multiverses and measures. So this is skipping back to where I said the major objection to infinite multiverses was the measure problem. And so I want to say a little bit, and maybe it's completely off base. This is sort of more, this is very a priori stuff, which I know scientists tend not to like. But I think this is one case where the a priori is in fact exactly right, because it's an epistemology problem, not a physics problem. It's a problem. It's an epistemology problem which needs to be informed by physics, of course, but it's fundamentally an epistemology problem. So here's how I'm going to set up the problem. There are infinitely many observers. You could call them sites. I'll just call them observers. Maybe you could have alternate formulations. Maybe you think the correct sites are types of observers, or observations, types of observations, or proxies for some or more of these. Right? So they're infinite, but let's just say there are infinitely many observers. Because little of what I say will depend on those kinds of details. In my reference class, so I'm one of them. There's some kind of reference class. Maybe all the ones, I kind of like the one where it's all the ones that share my subjective state, apart from some piece of evidence E that I'm trying to evaluate, whether the probability that I observe that piece of evidence. So I've got some reference class, all the observers relevantly like me, and I suppose they're infinitely many. On multiverse theories where there are only finitely many, none of what I say matters. Infinitely, moreover, the interesting case is one where infinitely many of these observers observe E, and infinitely many do not. Right? Cases where they all observe E are uninteresting, which is sign probability 1. Cases where none of them do, is sign probability 0. Cases where finitely observe and infinitely don't, or the other way around, you can also assign 0 or 1 if you like. Not a problem. The big problem is when infinitely many observe and infinitely many E and infinitely many do not observe. With equal cardinality of infinities. Maybe you have some higher cardinality than maybe you didn't say something. I'm going to actually assume the cardinality is accountable in all these cases. Moreover, and I'm going to call all this stuff on this first slide as the scenario, the setup that I'll be assuming. I have information about the arrangement in space-time, or otherwise, some de Sitter space, or whatever, some configuration space, whatever. I have information about the arrangement of the members of this reference class K and the distribution of observation E in that arrangement. Right? So maybe I know the observers are balls. and two of them observe it, and next to them is one that doesn't, and so on. I have this information. Right? Currently, science doesn't have all this information. But suppose I do. This is right, I'm assuming sort of the best possible case for getting measures where I have even complete information about this arrangement. The one thing is that I don't know is which one I am, which of these observers I am. That's the one thing I don't know. And I think something like a self-sampling assumption is very plausible. And I'll say a little bit about that. What I want to know now is to what degree I should expect to observe E. This could be a case of prediction, where I'm about to do the experiment and hence I will see E, and I want to know with what confidence I should expect E. Or it could be a case of old evidence where I already see E or have seen E, but I want to know how likely that was. But it's to what degree I should expect to observe E. This is, I think, an epistemology question. Epistemology is a study of what is rational to me. It's a question of what I should expect to observe. So here's sort of my tendentious way of seeing this. My tendentious way of seeing is, here's what physics tells me. Physics tells me the arrangement of the members of K and the distribution of E. Maybe not physics, the particular theory I'm evaluating, let's say. The particular theory tells me what the arrangement of the members of K and the distribution of E among those members is. Maybe it tells me, here's how stuff looks. Now I want to know what I should think. How much confidence I should have in E. What I should rationally infer. Which theory I should prefer to which. These are all should questions. They're rational should questions. And as such, they're epistemology questions. Physics doesn't answer should questions. Science doesn't. That's the great merit of post-Aristotelian science, is it doesn't answer. Is it leaves alone should questions. Because it just gets too bogged down. You ask, should people have sharp teeth? Now, my big claim is that in a situation like the above, I don't mean just this one, I mean anything instantiating these parameters, infinite set, where everything's of the same cardinality, infinitely many observers of E, infinitely many of not E. I have information about the arrangement, but I have no information as to which of the things in the arrangement I am. In any situation like that, I cannot make any non-trivial probabilistic assessment of how likely I am to observe E. That's like that. If you like probabilities to be, if you say, well, but probabilities could be intervals of uncertainty, then I can say, yeah, okay, there is one. It's the interval from 0 to 1. That's the one I'm willing to assign to it. But that's not helpful for anything. And for simplicity, like I said, I'll assume the infinities are all countable. Things get complicated when they're not, but I think it's not going to matter. In infinite multiverse scenarios, and some infinite universe scenarios, and the ones that have enough variety, and things don't just peter out, I'm in the above situation with respect to all my observations, because they're going to be near duplicates of me making bunches and bunches of observations. So this is a very radical case or question, right? It's not just about getting, the measure problem, as I see it, is not just about getting cosmological predictions.
Just in the multiverse scenarios or the big universe scenarios that we were talking about earlier in the workshop, the situation is more like there are bunches of observers who think they're making the same observations, but in fact aren't. That is, they're in the brain state that you're in immediately after having made an observation, including a memory of making an observation and getting a certain result and so on and so forth. But for the vast majority of those observers in the Boltzmann brain type of situation, it's just not true that they made those observations.
Well, it depends on what you mean by
made those observations was just one, or maybe very few, or something like that.
I mean, it depends on what you mean by made the observation. If the observation just my present subjective state.
Yeah, no, that's not what I mean.
Observation.
What I mean is they have. What I'm referring to.
So if the Boltzmann brain problem is there, then there's a way in which all of this is maybe moot.
Okay.
But I also suppose it's not there.
No, fair enough. Okay.
This is an in-principle objection.
Sure, good.
So it's not about Boltzmann brains. It's whatever the setup is. Maybe there are no Boltzmann brains. Maybe it's a law of nature that there are no multiple brains.
Right.
In a human picture, that could be a long picture.
Suppose we're trying
Very
to,
informative.
suppose you're trying to explain our universe, not some big multiverse. And suppose that the basic physics that we're presuming is connected with this inflationary start, where as in a multiverse scenario, there's a quantum tunneling phenomenon or something like that, which is in principle unpredictable, just like a radioactive decay of a single atom. So the question is not predicting, measures on all kinds of possible. The question is trying to understand whether your PSR is relevant to this case. I would guess that it's not, because this is absolutely a chance phenomenon, and like all such individual chance phenomena in quantum mechanics, we don't expect to be able to predict that it occurs or the details of when it occurs or anything like that. Doesn't that completely invalidate your entire approach?
I don't think so.
Why not?
But I'm talking about something else now. I said what I think about quantum explanations in the previous set of slides. Right now I want to say, let's assume we've got infinitely many observers of a relevantly similar type. What can we say? And then we can go back to these issues tomorrow. Like I said, I want to leave the big questions open in the interest of getting through at least a little bit of this material. So I think this is not just about cosmological predictions, it's about ordinary day-to-day predictions. I roll a die. What's the probability that it'll be 1? Well, you've got infinitely many observers who will get a 1, infinitely many who won't. In our scenario, right, there are infinitely many people in each state. If you use proxies in the measurements, it gets a little more complicated how you do it for things that happen to not the proxies, but the particular persons. But that's okay. For a simple cutoff and limit measure, a strong law of large numbers gives us, in fact, the right answer for the die, right? You look at the limit of the number of I less than n, such that the ith observer rolls 1 divided by n, and by the strong law of large numbers, assuming that it's all measurable and nice, we get 1/6 in the limit, which is in fact the correct answer from this simple measure. If the measure doesn't work, I think I cannot make any probabilistic assessments. Because if I'm in the multiverse, I am in the scenario I described with respect to every observation I make. So all empirical science is overthrown, because I cannot make any probabilistic assessments. So any scientific argument for such a scenario is self-undermining. And this is very general. This doesn't depend. If the arguments are going to work, which they might not, they're going to cut regardless of the detail, as long as we've got all the infinities right. So let me start with this, see how much I can get at that. So probabilities theory of the sort of modern, really modern sort starts with Kolmogorov in the first half of the 20th century. And this is sort of what mathematicians mean by a probability. It's a function from a sigma field F on a sample space with the real numbers satisfying 3 axioms. The first is it's always non-negative, right? Should be all fairly familiar. The second is it's normalized. And the third is countable additivity, which we'll end up seeing is very crucial here. If you've got a whole bunch, a countably infinite sequence, or maybe if you've got a countable sequence of finite or infinite of sets which are pairwise disjoint, their intersections are empty, then the probability of their union is equal to the sum of the probabilities. And so what's the probability? This is true for finite case. What's the probability that I will roll a 1 or a 2? It's the probability that I will roll a 1 plus the probability that I will roll a 2, because the events of rolling 1 and 2 are disjoint. There's no way of having both together. But this also holds for countable unions on classical probability theory. And all the standard theorems, just about in the literature, assume all of these axioms. A sigma field is a non-empty set of subsets closed under complements and countable unions, and hence countable intersections. In our scenario, omega, the sample space, is the bunch of observers. And what I want to know is how likely I am that I'm one of them. That's what I want to measure on, is the space of observers. And we want to know the probability of the set E star, which is a set of all those observers that observe E. That's what I want to know. But to do that, I want to measure on not just E star. That will be kind of ad hoc. I want it to apply to all sorts of other things. One standard way to get measures is to cut off the limit methods. You want to know what the measure of U is. You take the limit of the size of the set A you're measuring intersected with UN, divide by the size of UN, where UN is some expanding sequence of finite sets whose union is K. So like if you have the simple case where you've got just a bunch of people arranged in a straight line with a first and second, third, you could take UN to be all the people from 1 up to N. Quick fact, right? If you've got this cutoff and limit method, measures. Oh no, yeah. If I've got that, then here's something fun. The measure of any one individual point in the space omega is 0, right? Because the numerate, the top here is 0, then eventually once UN starts including that observer, it becomes 1, but it's never bigger than that. UN goes to infinity, and so the limit is 0. Okay, but look, observer 1 plus observer 2 plus blah 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 is K. So we violate this axiom. Because we've got these disjoint sets, namely the set containing one observer, the set containing a second, and so on. They're disjoint, and this side is 1, but this side, this is 0, this is 0, this is 0, and an infinite sum of zeros is 0. Moreover, in further violation of the axioms, nothing, terribly wrong in principle of violating axioms. All the time we violate axioms. We just choose the ones, we just say they're not the relevant ones. But in this case, I'll argue that they are relevant. Mu is not defined on a sigma field, or even a field. It's easy to find cases where the limits defining mu A and mu B are defined for any kind of cutoff measurement. But the limit defining the measure of the intersection is not defined. Okay, so you say, well, who cares? Maybe so you violate the axioms. What you do then is, what you might want to do then is you weaken the axioms. Right? Those axioms, we can't have those with any kind of decent measure, so we modify them. Standard way to do this sort of thing for epistemologists, at least working on infinite sample spaces, and probabilists like De Finetti who think about these things, is you say, well, the problem is this axiom. This axiom makes it impossible to have a countable number of cases where each individual case has 0 probability. But we want to have that in these infinite cases. Any of these limiting measures, we're going to have to violate this. So we want, but there's something right about K3. Probabilities should add up. So we replace K3 by K3F. For any 2 sets that are disjoint, the probability of your union is the sum of the probabilities. Very simple modification, very natural. And we only require the field to have to be a field, namely, we don't require it to be closed under countable unions, just under unions. We call this a finitely additive probability. And people like De Finetti have thought this is the right way to go. Various things. There's some good news. Theorem. Very simple theorem. If you do non-standard analysis, it's just obvious. There's a finitely additive probability mu on all subsets of K such that the measure is equal to this limit whenever this limit is defined. So you can take the limit measure and extend it to a finitely additive measure. Yeah.
Just following up on this idea that the Komarov axioms might need to be modified in order to solve the cosmological measure problem. Because it's fundamentally a quantum mechanical problem, there is a view that in the, let's say, the quantum Bayesian perspective, that something like the Born rule is essentially like a new axiom that's added on top of the standard Komarov axioms. So that it may be that part of our problem with trying to solve this measure problem is that we really are starting with the wrong axiom.
So we not only add the Born rule, but we remove something as well.
Well, perhaps. I
But the problem comes if you have the axioms. So adding more axioms won't help. You have to subtract axioms. And there are good arguments for why you want these axioms, like arguments about all sorts of really weird game theoretic behavior that you're going to get if you don't have these axioms. At least with finite additivity. And I'll say a little bit more about the infinite. So yeah, easy theorem, you can do this. You can come up with a finitely added probability. That's good news. Another beautiful piece of good news, and I like this, is I can prove this little theorem that the central limit theorem and the weak law of large numbers hold for finitely added probabilities, at least if you have boundedness on the variables, and you can actually do it under various weaker assumptions. I don't know if that's in the literature or not. It's actually not hard to prove. You can prove that you can approximate countably additive variables by finitely additive ones, and use limit theorems that have explicit error bounds. Okay, so that's really good news. It seems like we can do a lot of the stuff that we do in classical probability without countable additivity. There's bad news. While mathematically interesting, finitely additive probabilities aren't good for epistemology, and we're doing epistemology. Here's why. At the heart of the epistemological use of probabilities, say think of Bayesian stuff, or likelihoodism, or any kind of theory of reasoning, somewhere conditional probabilities end up coming out. We want to know how likely is this theory on the evidence, or how likely is this evidence on the theory. We want conditional probabilities. And there's a nice classical definition of them, at least that works whenever probability of B is not zero. Some good questions about what to do when probability is zero. Classical probabilities share this neat little property. Suppose you subdivide omega into a bunch of disjoint subsets of positive probability. You cut up your sample space into a whole bunch of subsets. Maybe if it's people, you cut it up into the blue-eyed people, the brown-eyed people, the people who have no eyes, the people who have a color of eyes other than blue and brown. Let's assume nobody has both a blue and a brown eye, making them disjoint. Right? So you can partition the space into disjoint subsets of positive probability. There might be infinitely many such subsets. And suppose that no matter which subset you're in, the conditional probability in that subset is at least alpha. Well, if P is conglomerable, then the probability of B is bigger than or equal to alpha. I mean, think about it this way, right? You think of a partition as like an experiment. An experiment tells you where in the partition you are. You do some experiment, and it tells you, it's going to give you one of a range of results. If you have conglomerability, suppose you know that no matter what result you're going to have, your probability for B is at least alpha. Well, then you don't even need to do the experiment. You already know that your probability for B should be at least alpha. At least if all you want to know is whether it's bigger than or equal to alpha. It might give you some more information. If probabilities are non-conglomerable, then you can have an experiment where for every result of the experiment, your probability will be bigger than or equal to alpha, but your current probability is actually less than alpha. And you know that. And that's rational. Because these are rational epistemic probabilities. It's really weird. So you know it's going to be bigger than alpha after the experiment, after you get more data. But now you're stating that it being less than alpha? Why? Surely you'll be better off with more information. That's weird. That's reasoning so when you have a violation of conglomerability, you can have reasoning to a foregone conclusion. Namely, you know ahead of time how the experiment is going to go. Or you know which way your probabilities will go. But the crucial thing about probabilistic stuff is you don't know ahead of time how things will go. If you did, you would already adjust your probabilities in the direction that you know they're going to go. So non-conglomerability is really kind of counterintuitive and bad. So Kadan, Sherbish, and Seidenfeld show that you always get reasoning before a conclusion in such cases of non-conglomerability. Here's an example of non-conglomerability. And of course, this has something to do with measures. You and I independently and uniformly get numbers, mu and nme, from among the natural numbers. There's a well-defined finitely additive probability. Just take the the cutoff and limit measure and extend it to finitely additive one. So you get these numbers. The person with the bigger number counts as a winner of the main game. Really. Each person sees their own number first before they see what the other person's number is. Here's what you know. You know that no matter which number n you will get, the probability that my number will be bigger, your probability then that my number is bigger will be 1. Here's why. Suppose you're going to get the number, suppose the number you get is 1,000. Well, you sure well know that a random number among the natural numbers is almost certainly bigger than 1,000. And of course, the cutoff and limit measure does say that. It says the probability that it's less than or equal to 1,000 is 0. It assigns 0 probability to all finite subsets. So you know ahead of time that you're going to despair when you see your number, whatever it is. If it's 1,000, you'll despair. If it's 1,000,000, you'll despair infinitesimally less, but you'll still despair because you'll be sure that you will lose as soon as you see the number. That's non-conglomerability for you. Now let's make this more fun. If somebody adds a standing offer of a side bet before both numbers are revealed. Here's the side bet. If your number is bigger than mine, you get $1. If your number is bigger, if my number is bigger than yours, you get $1. If your number is bigger than, it's sort of a consolation prize, right? You lose the main game, but you get the side bet that you at least get $1 if you went for this side bet. But if your number is bigger than mine, you're going to pay me $1,000. Sure doesn't seem like a good deal. Right? Ahead of time, before the game starts. But once you find out what your number is, you're going to jump for this. Because your probability that my number is bigger than yours is going to be 1. And so, almost every time, right, you're just going to keep on paying me those thousands of dollars if we keep on playing this game. It's just going to be silly. So in fact, after you see NU, you assign probability 1. In fact, you should be willing to, if ahead of time you can pay me, you can pay the experimenter not to show you what your number is, you should do that. Because as soon as you see what your number is, you will go for this stupid bet. And you know you will. So you should pay the experimenter $500. Maybe, is that right? Maybe less than half, $400, let's say. You should pay the experimenter $400 not to see that number, and you'll make a better decision with less information. So, this case of non-conglomerability is a violation of Good's theorem. Good's theorem is a really nice theorem in decision theory that says you should never pay not to find out the result of an experiment if you're a rational decision theorist and there's no extra stuff. You're not going to be psychologically ruined by knowing something and stuff like that. As long as everything is perfectly rational, you should never pay. These non-conglomerable probabilities violate Good's theorem. You should sometimes pay not to know. In fact, Cadan, Shervish, and Seidenfeld show that non-conglomerable probabilities always fail Good's theorem. And the kicker, all merely finitely additive probabilities are non-conglomerable. That's under the theorem that Shervish, Seidenfeld, and Cadan. I guess the same people, in a different order, proved in 1984. And they're a bunch of sort of CMU philosophers / statisticians. And so in some situations, every non-conglomerable, every finitely additive probability that's merely finitely additive, that's not also countably additive, results in reasoning to foregone conclusions and paying not to know. And probability functions like that are epistemically bad. So all the cutoff and limit ones have this bad property of being at most finitely additive, and hence they do not seem to correctly represent things of epistemological significance. They do not seem to correctly represent what the rational degrees of belief should be, because rational degrees of belief should not be such as to license reasoning to a foregone conclusion or violating Good's theorem, paying not to get information. So they're fishy, epistemologically. And in fact, I'm going to just give a quick argument that all the measures that I think are
have a hope of being plausible are like this. If I have no evidence distinguishing them from anyone else in K, then for any two observers in K, the probability that I'm one of them should be the same as the probability that I am the other. Just for any pair of observers, with no information to distinguish them. Well, right, suppose I think I'm more likely to be OI, and you're also a member of K. Then we can have an argument. And presumably you're going to reason just like me, because I'm perfectly rational, and I'll charitably assume you are too. So you think you're more likely to be OI, and I think I'm more likely to be OI. And we've got exactly the same evidence. We can share our evidence. We can pull all the stuff we know. And we will still each think that, and I'll still think you are more likely to be OJ. And you will think the opposite. That's really weird. I mean, maybe it's not utterly absurd, but it is really weird. And it just seems to me intuitively clear initially that the probabilities of being two observers should be equal. Now, if you have causal diamond kinds of measures where you only count a finite subset of the observers, you're going to fail this condition. But I think that's a reason not to have those kinds of measures. Because I do think the observers outside the causal diamond, if they're on par with you, should count just as much. And by on par, I mean they've got the same subjective states. Self-sampling should include them. That's controversial. So if P is a decent measure on K, all the probabilities are the same. Okay. We suppose it's finitely additive. So 1 is bigger than or equal to the probability of O1 through On, which is equal to the sum of these because it's only a finite sum. Oh, and that's n times the probability of O1. So for every n times the probability of being O1 is less than or equal to 1. Oh, there's only one non-negative number that's less than, that satisfies the property that 1 is bigger than or equal to n times it. And that's 0. So this must be 0. Or infinitesimal, but you can try to assign infinitesimal probabilities. It won't get you anywhere. I mean, there's sort of lots of results showing that you won't get anywhere helpful with that. But if you do, I mean, the quick thing for here is they're also going to be non-conglomerable. So the probability of each outcome has to be 0, as in the limit and cutoff measures. And so our measure is not countably additive. We saw that already. And so then it's got all the other defects that non-conglomerable measures have. So there's actually a very good reason that wasn't known until, I think Dubin's in the 60s as to why the Kolmogorov axiom requires countable additivity. Why it is that good probabilities should be countably additive. It's that if they're not, you've got non-conglomerability, which makes them not a good model for epistemic probabilities. It's a surprising fact. It may be that the kinds of cases that I've come up with are not the kinds that are going to come up in practice of physics. But I think the fact that the measures lead to such paradoxes show they're not the right way to measure epistemic probabilities. Epistemic probabilities should be something like a measure over all subsets or all measurable subsets. And these just aren't going to cut it if you've got this kind of indistinguishability assumptions in the first round, as I think you should have. I will very quickly give this and then stop. This is a really fun story by Hudson told me. Imagine you've got a bunch of red and blue balls on the table. I'm somewhat varying this. An angel appears and tells you that one of the balls has your name in it. In 10 days, you will get $1 million if the ball with your name inside it is blue. Oh, and you can't repaint them or anything like that. They're permanently colored. You can't open any of the balls, you can't look into them, but you can rearrange them however you like. You can ask the angel's help for arranging them however way you like. Maybe you can arrange them so they hang in midair. The angel can do all that. Is there any arrangement that increases the probability of your getting $1 million? No. But suppose there are infinitely many. And you ask the angel to arrange them in a line, so that the red ones are powers of 2, and the blue ones are not. This seems to increase the probability that the unknown ball is blue if you have something like a cutoff and limit measure. Because most of them, according to at least one where the cutoffs work like this, because most of the blue ones are going to be
favorable to you. But your cleverness, I think, is misspent. The order of the balls will not change the probability that a ball with your name on it is blue. And I think the lesson of cases like that is that the physical structure doesn't actually matter when assigning epistemic probabilities to the question of which observer in this set you are. What matters is which observers have observed you, which do not, how many there are of each, but the physical structure doesn't matter. You could rearrange it. Imagine God sort of creating a world and it has lots of souls in front of him. You can put the souls into bodies however way you like. But he's already decided which souls are going to get a good life and which are going to get a miserable life. No arrangement of bodies is going to increase your chance of getting a good life. Not even if you arrange them so that, like that, the blue one's getting the good life, or ask God to arrange them like that. It's not the physical structure, it's the permutation structure that does it. But there are no measures that are invariant under all permutations. There are no finitely additive measures that are invariant under all permutations. That's just an easy little probability fact.
So we're going to spend a little time with questions for Alex, especially I think about N, which he just sort of presented, but we didn't get a chance to talk to him about. And then we're going to have a talk about quantum mechanics, and Joel will introduce our next speaker. So
I just want to put up one slide. This is somewhat related to the measure stuff I talked about. This is just a fun puzzle I've been sort of puzzling over for a while. Don't know what to make of it. So you've got the story is that Smith tosses a die, doesn't get to see the number. On each of the next 6 days, he's taken by the organizers of the game into a room. And in that room, there's a sealed chest that can't be accessed by you or Smith or anybody else involved except the organizers. And on that chest, there will be Smith's name. Or in that chest, there will be a piece of paper with Smith's name, if and only if the day number is equal to what Smith's die showed. So if Smith's die tossed 3 on all the days but the third day, the chest will be empty. It will not have Smith's name on it. But here's a twist. So now you wonder, you see Smith in front of a chest on day 4, say, and you wonder, what's the probability that Smith's name is in the chest? Well, it's 1 in 6. I mean, that's the probability that he rolled 4. Okay, complicate things. There are infinitely many players of the game. And, what do you expect? Well, if there are infinitely many players of the game, countably infinitely, presumably, for each of the 6 possible die throw results, infinitely many people get that. I mean, that's what the law of large numbers predicts. Okay, so that's what we're going to have. And the organizers, or some kinds of beings that can move faster than light and all that, pair them up in such a way that when the players don't get to see the chest, they go into different rooms to see chests, but they always do it pair by pair. And with the following property. Each chest contains exactly one name, namely the name of one of the 2 people who gets to see it on that day. The other property is that nobody's ever paired with anybody else. I mean, twice. Nobody's ever paired twice with any.
Smith is always with Jones on all 6 days.
Yeah, that doesn't happen. So everybody gets a different pairing on every day.
oh.
So
they're never paired twice with the same person.
Right. Sorry for the typo. It was very late when I was writing this part.
It was during the party, perhaps?
No, it was actually the night before. I could have proofread yesterday during the party, but I didn't. Okay, so this can be done, right? I mean, you can pair them up in such a way that on each day, a person with their name in the chest is paired to a person not with their name in the chest. And you have no idea what kind of algorithm the organizers use to arrange this kind of pairing. Maybe they come up with some random ordering of the people and then use that to come up with this kind of pairings.
All right, so we've got this weird setup, which is possible if you can have infinitely many people and beings that can arrange them in weird ways. And now you come along and you see Smith and Jones in a room. And let's say it's day 1. So there's Smith and Jones in a room, and it's day 1. And you think to yourself, what's the probability that Smith's name is in the chest? Well, you have one thought. Either Smith's name is in the chest or Jones's name is in the chest. You've got no reason to think one hypothesis is more likely than the other. So you say it's 1/2. But then you think another thought. Smith's name is going to be in the chest in the room, in whatever room Smith ends up in, on exactly one of the 6 days. And Smith obviously had a 1 in 6 chance of tossing 1, in which case his name is in the chest. So the probability is 1/6. So 1/6 equals 1/2. Or something's wrong with one of the things I said. Okay, I'll shut up. If you have a solution, you can tell me now, you can tell me later, or you can ask about anything else. So I'm interested in whether or not you think the PSR, as you defended it, can sort of be made to be consistent with libertarian accounts of free will, and what it would mean to have an explanation of an agent's freely acting on the basis of some reasons.
Yeah, I mean, I think I think you just do what I said for the kind of quantum case. Why did Jones eat the ice cream? Because Jones really liked ice cream. Why, in another possible world, Jones doesn't eat the ice cream. Why doesn't he eat the ice cream? Because he doesn't want to get fat. Now, in both cases, it's true that he likes ice cream and doesn't want to get fat. But only one of the two is explanatory in each of the worlds. Namely, the one that actually led to his choice. And either one could. Yeah.
So,
sorry, you should go ahead.
do you want to follow up? Yeah, sorry. So what about the God case? Right, where God is freely acting. Let's say, like I was interested in the proposition the other day, that God explains the BCCF, right? Mm-hmm. So you said something like, well, I think that God himself just explains that proposition. But I'm confused as to how that story would go, because I thought there was an assumption here, namely that proper relative explanation relations are propositions. So you're not saying that the individual, God himself explains this proposition. You're saying something like the proposition that God exists, or like, so which proposition is this that explains?
Pull up this slide.
That explains the proposition that God explains the BCCF.
Yeah, let me just pull up the slides for that part of the talk. It was in my response to the Van Inwagen objection that I gave a suggestion for what could be the story.
Yeah, so I mean, we sometimes intuitively say, we sometimes loosely say, you know, what explains something, and we give a name of a person. Like, what explains this person's death? It's the butler. But what we really mean is that some proposition about the butler, like that the butler did it. So in this case, yeah, sure, you can say God explains the BCCF, but that's a loose talk. And the more precise statement is that some proposition about God explains the BCCF.
And so one suggestion might be what I have here, right? There is a necessary all-powerful being B such that B necessarily values these goods, and BCCF necessarily includes these goods. Like, that's what explains it.
It's analogous to the explanation Jones ate the ice cream because he liked the ice cream.
namely, Jones is a being with, you can spell out the Jones thing, Jones is a non-all-powerful being with such and such powers who values the taste of ice cream, and eating ice cream includes the good of the value, includes the value of eating ice cream, and that's what explains why Jones ate the ice cream. What explains why God created the BCCF was that God valued the BCCF in the following ways. And I don't know what those following ways are. It's only a sketch.
I mean, this proposition is going to have to be necessarily true. And so now I'm sort of wondering why this proposition doesn't explain the proposition that God explains the BCCF at other worlds.
Because the BCCF is false at those other worlds, and you can't explain what is false.
Well, but so if the idea is though that this particular proposition explains that God explains the BCCF, and we move to another world in which the BCCF is false, but I mean, so the idea is just that the exponents the idea can't be that the exponent fails to be true, the exponent is still true there, but it just ceases to do exponential work. And so I guess I just want to know
because
why that's the case.
Because the entailment principles, well,
right.
The entailment principles is false.
false.
So yeah, so the same, that proposition is still true. I mean, look, take the free will example. In the case, Jones could have chosen to not eat the ice cream because he doesn't want to get fat. And that could be true, despite the fact that he wants to eat the ice cream. Not wanting to get fat does not take away the desire to eat the ice cream. You can have both desires, and you can choose to act on the one, or you can choose to act on the other if libertarian free will is the correct theory, and you were asking me about libertarian free will.
Yeah, so, well, it seems to me as if, and I'm wondering if you think this is correct too, that there's going to have to be some kind of theory of freedom akin to the libertarian account, if not the libertarian account, in order for your response here to run. I mean, I'm not necessarily, with respect to the question of what explains, God explains the BCCF, I'm not necessarily interested in, offering sort of like libertarian free will as something that might be problematic for you. I'm just wondering whether or not, in order to get the right kind of response to this query, you have to invoke something like libertarian free agency along with some sort of agent causal power theory or agent causation theory.
I don't know about that. I mean, it depends on whether libertarian free will requires agent causal power or not.
I mean,
but if it does, well, then no problem adding that to the story because we're free and we presume it will happen. Why couldn't God have it? If it doesn't require it, not a problem either. It's just, yeah, sure. I mean, there are lots of questions about free will that you can ask. What would be damaging, though, to this story would be if libertarian free will was incoherent. So for the non-philosopher, the philosophers have two sort of main views of free will. One is a compatibilist view on which freedom doesn't have anything to do with alternate possibilities. It's not that you can make free choices without any, well, there's only one option that you can possibly choose. What makes an action free on this account, and this is Hume's account, is that it flows from your character in the right way, and your character has been produced through the right kinds of processes. So for instance, without brainwashing, without external compulsion, and so on. That's what makes your action free. And so your action could be entirely determined by your desires, beliefs, goals, and all values, and all that. And it could still be free. The other main view of freedom, from the people who think there is freedom, is the libertarian view, on which, while we do have freedom, freedom requires something like alternate possibilities. It requires that at least at some point, a free agent have two possibilities of going. There is some kind of indeterminacy. Some physicalist libertarians make there be a quantum indeterminacy in the brain. Non-materialist libertarians make it be something else. But in any case, you have these two views. Now, if you're a compatibilist, you could still think you could still think that choices don't have to be determined by conditions prior to choice. But some compatibilists make the further claim that they have to be determined. Hume made that claim. He thought a free choice has to be determined by your character, otherwise it's not really yours. If it's not completely determined by your character, it's just random if it's not determined by your character, Hume thought. If you take that view, and if you have a necessary being, which necessarily has some kind of nature which sets values, namely, if it's a perfect being, it'll value all the things that are in fact valuable to the extent that they are valuable, then on this kind of compatibilist view, that perfect being will only be able to choose one option, will have no alternate options. And so this will, an explanation like, in terms of a being like that, will undercut the contingency in the world. And so if you have this compatibilist view of free will, which requires determinism in free will, it's not going to work with the stuff I said. You need either a libertarian view or a compatibilist view, which there are people who defend it, on which you don't have to have determination.
So since we're on this slide, I was trying to sort of codify my discomfort with the suggestion that a necessary truth can be thrown contingent upon.
Yeah.
And so obviously I agree that entail is false. But it's plausibly a necessary condition for P to explain Q that Q is counterfactually dependent on P, which is to say that the counterfactual, if not P, then, well, if P hadn't occurred, then Q wouldn't have occurred, is non-trivially true, something like that. And that's, counterfactual dependence isn't the same as entailment because, you know, if the short circuit hadn't occurred, then there wouldn't have been a fire, even though it's not the case that in all possible worlds in which there is a short circuit, there's a fire. Because there are some worlds in which there's no oxygen around or something. But a necessary truth is not going to satisfy that requirement because it's always going to be trivially true. That if P hadn't occurred, then Q wouldn't have occurred, where P is a necessary truth. Okay. So that's at least, I think that's kind of why I push back on it. And so I think it would be more faithful to the discomfort I have to engage with that version rather than entail. Because I think everyone agrees that entail is how it is.
Yeah, good. That's an interesting suggestion. I haven't heard that objection. So the suggestion is explanation requires a counterfactual dependence. If P explains Q, then were P not to hold, Q wouldn't have held.
P is what makes the difference to Q's current.
Yeah, or at least maybe more weakly, we might want to say if P didn't hold, Q might not hold. Maybe we want something a little bit weaker. I mean, suppose we take something like explanation by laws of nature, right? Suppose there were no laws of nature at all. Can we say that that particles wouldn't be arranged this way? I don't know that we can say that. We can say they might not be. So I don't know if we have. So maybe we can modify it. I mean, so there are ways of tweaking this, right? It could be Q wouldn't be true or Q mightn't be true, but both suffer from the same word, right? That what sense could there be in a counterfactual whose antecedent is impossible, where P not to hold, but P is necessary? Were circles square? What would happen?
Right.
I mean, so what I guess thought is this will undercut actually also explanation of necessary truths by necessary truths if it explains if it does that. And there do seem to be cases of explanation of necessary truths by necessary truths. In mathematics and in ethics maybe. So that's one of the words that overreaches. And others, maybe there are non-trivial per impossibility counterfactuals where, you know, it's just non-trivially true that where, you know, suppose the axiom of choice is necessarily true. It's non-trivially true that where the axiom of choice falls, there might not be any non-measurable sets or something. So there might be non-trivial counterfactuals that have impossible antecedents, or where, you know, were I the number 7, I would not be located in space-time.
So you need a non-possible world semantics of counterfactuals.
Yeah. And I think, and it is in fact one of the objections to possible world semantics of counterfactuals is it doesn't do anything for the ones with impossible antecedents. It's actually one of the standard objections is that we do actually make those counterfactuals with impossible antecedents. And the other thing, and this may be only technical because there may be some way of tweaking your objection, is that it can't be in general true that explanation requires a counterfactual dependence, because you can have things standing in the wings to produce the effect, right? So you've got the sort of in standard kind of case is you've got 2 assassins, and I'm one of them. Were I not to shoot a questioner who asks the really annoying question, my fellow assassin would. And so but my shooting this person explains why they died, and I am fully responsible, despite the fact that were I not to have done so, my fellow assassin would have done it. In fact, cases like this even show that you can have explanations where you don't raise probabilities, because my fellow assassin could be much more effective than me. Were I not to have administered this poison, my fellow assassin would have administered a much more effective poison, and so the person would have even been more likely to die.
Yeah. So one would hope there'd be a way of tweaking the
that there's some
simple
way.
analysis I gave that leaves the objections out to be.
Yeah, just like a slight follow-up on Alex's thing. I mean, it seems like you need to have a story about not just why, like counterfactual dependence. So like you might think that explanation requires counterfactual dependence, but it seems like there's really general, like really what we claim, which is just explanation requires some sort of modal coordination. Where like modal coordination is just there's some pattern or correlation between the world in which P is true and the world in which Q is true. So you can have that like external would be a species of that, counterfactual dependence would be a species of that. But I guess it seems like there's lots of kind of ways in which you might think that worlds can an explanation requires pointing to some proposition with which that proposition is coordinated. And it seems like necessary truths and conditional truths can't that character admit, as you said, it's not obviously that kind of criterion makes sense for cases where necessary truths explain necessary truths. But at least in the case where necessary truths explain contingent truths, I sort of feel like some principle of that sort is quite attractive. I don't really know how to rule this out, if that makes sense.
Do you think that's going to be satisfied in the case of stochastic causation?
But in that case, I guess the coordination would also take into account the probability measure of worlds. So potentially not actually if you're happy with stochastic explanations that say, P can explain Q when P is something like Q with a non-zero probability of occurring, then maybe this kind of sort of
Maybe we can have the coordination that there's some correlation that it's in the world where P can explain that P doesn't assign non-zero probability to Q in all worlds, but only in some. Yeah, I mean maybe there's some way of working it out. I'm suspicious whether one can work this out and still have a robust notion of stochastic explanation. If one can, maybe then one can try to handle. I can try to see what to say about that.
So Alex, just a remark, isn't this a problem if you make the condition that counterfactuals should account for explanation that you already assume some kind of determinism? This is just the old debate of Molinism and libertarian freedom. If Molinism can account for libertarian freedom, it's exactly the problem. If I already assume determinism, then my probabilities won't be at least objective probabilities, and then I can just ask what at the epistemological level counts for explanation, for stochastic explanation, but it doesn't. won't correspond to real probabilities. So isn't it a problem which is built in the concept of counterfactuals, which excludes, let's say, stochastic causation, or implies something which doesn't entail the other thing?
I don't think so. So suppose I shoot an electron in a mixed state at a detector of one of the pure states it's mixed between. Then it seems like I can at least have might counterfactuals, like where I do have shot a different electron in the same mixed state, it might have gone differently.
Oh, sorry, okay, so you don't say you have a weak notion of counterfactuals, you include the might.
So I can have a might one at least.
Okay, good.
And I might be able to have a, there will be some wood ones, presumably. I mean, it seems obvious that were I not to have shot an electron into the apparatus at all,
okay, no,
nothing, no measurement would have been taken. And in particular, this one wouldn't have.
I totally take a very strong notion of counterfactuals.
Yeah, so no, counterfactuals are not entailments or anything like that.
They're not, if you allow for might.
Yeah, but even non-might, even wood counterfactuals, I think, aren't like that. I mean, it's a good question, and I mean, there's some worries about whether there are any non-trivial wood counterfactuals true in a world that's through and through stochastic.
I'm just not sure about the example, because I think it's a good example. If that were the case that counterfactuals allow for might, then basically a minus the count of freedom would account for real libertarian freedom. Wouldn't it be the case?
Depends on how it's spelled out.
Yes.
I wanted to ask about the puzzle you were raising at the very end last time, and this kind of came up at the dinner table, but I didn't feel like.
Which puzzle?
The problem about a measure on the space of observers in my circumstances, if there's infinitely many of them in a multiverse. Now, it seems clear to me that Joel raised the question: if the multiverse just has a few universes in it, this is this is not relevant. But of course, that's precisely not the kind of multiverse you were talking about.
And any finite number is few in this context.
I'm sorry?
Any finite number counts as few in this context.
Yes.
No matter how.
Right.
Actually, my point was that there's only one that we can never measure, namely ours.
Well, so here's my question is, there certainly are views, there are multiverse views that have infinitely many observers in them, guaranteed to be there. And those are the ones that you're talking about. My question is, what physical theories imply this? Does an Everettian theory imply that all these guys are there, or does it not? And we went around the table, and maybe somebody answered my question, but by then I had tuned out. We're talking about something else.
Let's ask I'm a philosopher. I'm doing the if it's like that and this. So let's ask the physicist.
Yeah, that's.
Yeah. So well, I'll have to think a little bit about the Everettian context. So certainly, a version of theories that would give rise to that is just a regular infinite FRW universe with some kind of stochastic initial conditions. So as I discussed in my talk, but this has been a while ago now, if you have some kind of stochastic initial conditions, then what we believe to be a bound on the number of degrees of freedom that a system of finite entropy can have, then you get these recurrences spatially, and so you're always going to have infinitely many duplicates of any finite system. Okay. So that's one context. In the Everettian view, we would, if you just started with some individual system and you were looking at different branches, you probably have to make some case that the system lasts forever and has certain properties and that the phase space was infinite, so you'd have to, it would be a little trickier to get an infinite number of decohered distinct branches or something like that. So that's, but the context people mostly think about is I would say the eternal inflationary one, where you get an infinite space-time volume, and then with some sort of argument about stochasticity of initial conditions and finitely many configurations.
Would
But,
this, just a finger to that, just wondering, would any sort of like ultra large scale structure theory, any theory that would tell you about, any theory which would imply the following about ultra large scale structure, wouldn't it be the case that they would also have this sort of infinitely many universe, infinitely many observers problem, where that the story was something like, look, with respect to ultra large scale structure, you've got a background asymmetric space time, infinities upward, infinities downward, positive temperature, fluctuations, anything that can happen will happen, moreover this will happen in an infinite amount of times.
Any theory that has infinitely many Boltzmann brains is going to do it.
Yeah.
Yeah, well, I
least
would
they'll balance its
separate out
size.
the Boltzmann vein problem from the one that he's talking about.
Right,
Is that he's sort of presupposing that that's solved in some sense.
Yeah.
But, I mean, I had a question. This seems like a very interesting way of sort of formalizing certain very uncomfortable questions about the measures and infinities. And I wanted to see if, in what sort of sense this is a concern, in that, so I understand that you sort of started out with some countably infinite set, and then you sort of admitted some preferred ordering to that set. So you said we have a, say, spatial ordering of it.
Yeah, there needn't be a linear ordering. There's some kind of structure.
There's some sort of structure that gives you, makes a natural context for doing, say, a cutoff measure or something like that. Now, so there's one thing that could be true is that putting any sort of measure on that is just problematic. Like you just can't have an infinite setup like that and talk sensibly about probabilities. So that seemed to be the sort of case you were making. Another case you could make, another thing that could be true is that some such sets and preferred orderings are going to give you problems. And another case could be that there are certain questions that you're not going to get sensible answers to. And so I'm trying to sort of figure out...
And others that you will get sensible
And others that you will get sensible answers to. So an example that I was kind of thinking of that contains sort of what I'm trying to get at is, so suppose we took just an infinite checkerboard, right? But maybe we'll flip one black to white, so we have a preferred position on our infinite checkerboard. So there's just one violation of the symmetry of the checkerboard. So we have a center to it. So we can certainly take a cutoff measure by looking at volumes around that preferred position, and we'll get a nice convergence to 1/2. In almost any way that we do that cutoff, because the form of space is such that you'll, in any sort of reasonable way, the surface area effect will diminish compared to the volume effect. And so you'll tend to approach a nice 1/2 out of that. Now, there's another question you can ask, which are things like, how far am I from the preferred position? Where you're going to get into the weird sort of troubles that you were talking about, where whatever answer you get is sort of infinitely improbable, in that if you find your distance and then ask whether someone else will have a shorter or longer distance, with probability 1 they have a longer distance. That's the sort of puzzle that we were getting at with the bet. So that's the sort of question that seems to give very problematic answers, whereas the question of white versus black squares seems to be a reasonable question to ask and give you reasonable answers. Then there's another twist on this, which makes it akin to eternal inflation, which is that instead of a checkerboard, you take like a Poincaré checkerboard, which you can tile with black and white funny shaped birds and things like that. We know that. Now there's famous Escher paintings of a Poincaré disc. So now this gets much trickier, because even if you have your preferred position and you start taking cutoff measures, you find that what you get depends a lot on the details of how you do the cutoff, because the volume is dominated by the outer radius, because the volume is increasing exponentially with the radius that you're making your cutoff region. So there are inherent ambiguities, even when you ask questions like, what's the probability of being a black or a white bird, you have to be much more careful about how you specify your cutoff procedure, because you get ambiguities depending on the details of how you do cutoff. So it seems to me like what I'm interested in, eternal inflation is sort of the worst case scenario because it's got all these potential problems. But I'm really trying to hone in on whether these problems are telling you that you're asking insensible questions, or whether the measure is really insensible and that there are no questions that you can sensibly ask.
Yeah, that's a very fine question. So, I mean, one of the merits or defects of how philosophers think about things is that they take some answer to a question and then they ask, does this work really, does this method of reasoning or work in general? And if it doesn't work in general, then we are suspicious of it. And so that's what I'm doing. I take the measure on the checkerboard. A lot of people have the intuition that it gives the right answer for the checkerboard, for, what's the probability of black. But the very same measure also gives the wrong answers for other things.
Well, particular things like how far are you away from something.
Yeah, so it gives wrong answers to some things and answers that to a lot of people seem right, to others.
But what would be the right answer to the question of how far you are from the center?
I think it would be that there is no answer, but the measure gives one, and that's wrong. That shows that the measure gives answers where there are no answers.
What answer does it give to what is my expected distance away from the center? It's infinity.
Oh, expected distance. I was thinking, what's the probability that I'm within a certain radius of it, and you give 0 to that.
Yeah.
And then you get the various games.
But that's arguably the right answer. It's just that, it seems clear that once you admit various types of infinities, there are going to be weird, puzzling situations.
Sorry, is it a success if it gives a stupid answer to a stupid question? That's sort of the summary. Asking what I expect my radius to be. If I have a good method and gives a stupid answer, then I conclude that I've asked.
No, but why is it obvious that it's a stupid? I think Anthony is asking.
Yeah, it may not be obvious, but maybe that's what the measure tells. That's the way out of this. What the measure is telling you, that even though it wasn't obvious at the start, that's the conclusion.
So the answer. One way of taking this is we saw that we can't have the standard Kolmogorov axioms. I suggested, well, okay, maybe we can modify them and have finite additivity. If we do that and still think this is the right measure, then we're going to say, well, the answers it gives are the right ones for all the things that are measurable with respect to it. And in this case, it's going to be a whole field and all the subsets. But it doesn't. It gives bad answers to some of these. We could try to weaken the notion of a measure even further, right? We could try to come up. And I think that would be an avenue for future research, and a promising one. What axioms does this measure satisfy? Are these axioms adequate to giving us a measure that answers epistemic questions? And there's a lot of literature in decision theory by philosophers and statisticians on Bayesian inference and things like that, that suggests that you need at least a Kolmogorov axioms of finite additivity to get anything that gives plausible epistemic probabilities, and probably you need countable additivity as well to get sensible answers. Now that could well turn out to be wrong. I'm just sort of saying what the orthodoxy is in that field. But it would be that would be interesting. But I think I think the approach would be to look at it. So what alternate axioms can we find? What will they satisfy? And one worry I have is that the approach is driven here by thinking that these kinds of measures give the right answer in any cases is driven by something like a sort of intuition that there's a probability 1/2 that the square is black. And once one questions that intuition, it's not clear. I don't know that there's any good argument for that intuition. And the things I said about structure and rearranging balls suggest that probability, epistemic probability, shouldn't depend on how things are arranged in space. I mean, here's one thought.
Yeah, that's a different. I felt like that was a very suspicious discussion. You can come back to that.
Yeah, but let me say something about that discussion, though. So it seems like, so what is it, right? So there's spatial relations between objects, but there are all sorts of other relations between objects, right? There's spatial properties, but there are all sorts of others. We can use all sorts of properties for an order. Why the spatial ones?
Yeah, no, I think the
why would space matter epistemically? What's space got to do? I mean, all I have is this bunch of beings that, imagine I have just a bunch of disembodied souls. That's not what we've got. But we've got a bunch of disembodied souls. Some of them are observing, infinitely many observe E, and infinitely many of the disembodied souls do not observe E. What's the probability? There's nothing I can say. There's no ordering on disembodied souls. I mean, maybe you can order on something arbitrary, like which ones are happier, and you have ordering by happiness or something, or by virtue or something. But there's nothing sort of obvious that jumps out like the spatial or temporal orderings. But now I suppose, okay, so I've got these disembodied souls and they're attached to points in space in some way, in some metaphysical way, or maybe just attached to it by love. They love particular points in space or something. That's spatial ordering on them. Now they have a kind of spatial ordering, but that doesn't affect any of the epistemic probabilities. I wouldn't think that would change anything. And now I suppose it's not disembodied souls, but it's in mattered minds. Well, minds made out of matter. So I still doesn't seem to me to make a difference. It seems like what matters is the subjective states and how many of each kind of subjective state there are. But I know you don't share that.
Well, I think that there's a lot to respond to.
And none of this depends, on the possibility of disembodied minds. I mean, sometimes I think you can even do impossible thought experiments and get something out of it.
Yeah, so I'm not sure which one I want to pick up on here. So I think in that example, so in the ball example, I think that maybe I just misunderstood the argument. So there was part of the argument where he said we're drawing things out of this finite distribution of balls, and
I didn't say it was finite. I just said some distribution of balls.
Okay, so if it's finite, everyone agrees, that as long as you really don't know anything about the, correlations between the color and your probability of choosing them, that everybody knows what they're doing. Now, then, let's see, so one of the balls has your name on it. So right away, if you're talking about an infinite set of balls, then you're talking about a probability 0 event that you're getting your name, right? You're drawing a ball.
Well, no, because it's not a question of which ball is drawn. What determines whether you win is the color of the ball that has your name in it.
You will get $1 million if the ball is inside in blue. So you have to look at all infinitely many balls and find out which one has your name on it. And I think you're right that there is a real difference in sort of mindset where it matters to physicists if there are operations that you can do or sort of imagine doing or sort of operationally describe in some way versus things like looking at infinitely many and finding your name in this infinite set. But I think the assertion that was bothering me is that just the assertion that you made at the end that it can't matter what order you put the balls in, that the probability has to be the same. So you state the order of the balls does not change the probability of the ball.
Your reordering of the balls will not change the probability.
Yeah, and I think that's so why is that when you have an infinite set?
Well, I guess and I have a strong intuition. Look, the name is in one of the balls. It's blue or red. Move the balls around. That doesn't change which one it's in. In this case, I mean, actually, sort of fun thing here is that you could say this. I mean, here's an answer and maybe something of what you said points to this, maybe not. An answer that I kind of think would be, that I find the most challenging answer to this scenario is no. There's a reason why reordering the ball doesn't change the probability, because the probability is determined by the earlier ordering of the balls when the experiment starts. And sure, you can afterwards reorder them in some other way, but it's the earlier one that counts. And that would be an interesting suggestion. I mean, one would wonder why. I mean, does it have something to do with the past hypothesis or some other account of the asymmetry of time as to why the earlier arrangements are the ones that give us the correct measure while the later ones don't?
I'll stop now.
Just to say something on that, I mean, the reason you might care about the earlier arrangement is that you care about how your name got into the ball. So you want to know something about how that ball was chosen to put your name into it. And if there was a certain arrangement that you came across, there's sort of some reason to expect that maybe that was the way the ball was chosen that your name was put in. Whereas afterwards, if it's rearranged, you know that the new arrangement doesn't have anything to do with how it happened that your name got put in the ball. Yeah, but in the multiverse scenario, unless you've got some theistic one on which God first decides which souls to create and then decides where to put them, there isn't any such thing as a method by which it's determined in which of the many universes you've been put. So I've done it with the balls here. I mean, another option is, right, you are in fact in one of the balls. You can't see the color on the outside, but you can ask the angel to move them around into any pattern you see fit. And you don't get to see the patterns. And so you say, I want this pattern here, because that's the one that maximizes the chance that I am in a blue ball. And that seems silly. But why is it silly if the order in fact matters for the probabilities? Especially if there's some kind, especially if you don't have a strong picture of the asymmetry of time. Maybe if you do have a strong picture of the asymmetry of time, you could insist the earlier order is what's determinative. If you don't, you just, why the earlier, why not the later one?
So here's an analogy, and I can't decide whether or not I suggest it, but you've got a hotel with a finite number of rooms, and it's full up. Yeah. And you want room 3 to be available or something because it's your favorite room. And you can only rearrange the people in the room. You can only sort of take people from one room and like swap them or something. You can arrange people however you like. Is there going to be anything you can do to make room 3 available? No, clearly not. Go to an infinite number of rooms, infinite number of people, so it's full up. Is there something you can do to make room 3 available? Yes. Just tell people to move to the room that's twice their own room number. So look, I don't know if this is relevant to here, but it seems like there are going to be difficulties with extrapolating from intuitive judgments about the relevance of rearranging things in the finite case, which to the infinite case, which actually don't work.
Right. I mean, obviously the infinite is very different from the finite, and that's precisely why we've got this measure problem, right? I don't find that I mean, this is just autobiography. When I think about this case, I don't find that finiteness has anything to do with the thought that rearranging the balls won't change. It doesn't matter for the probabilities. But I could be wrong. I find the difference between the finite and the infinite could be more deeply embedded in my thinking than I think.
We have time for maybe one more question. We need to start the next talk conflict at 11. So, any final questions? Remarks? Remarks? Nothing quick. You have a long question.
I don't think it's a question.
How about a useful non-question?
After the question, the attenuation multiverse probability problem?
The pessimistic thing is that our probabilistic tools just cannot work there. And if anything is going to work there, either we just can't you can't make any predictions in a case like that, or we need some completely new conceptual tools. We need a new decision theory. We need an alternative to probability-based epistemology. Something deep new thinking is thinking. I've got a colleague who's really annoyed with me because I keep on coming up with all these paradoxes and problems, and he really wants me to come up with solutions, but I'm not smart enough. All I can do is come up with
Second
problems.
question, just very short, so a second love question. So would you then think that this is, so what does it mean for the physical theory? Should we be happy with this and say, okay, now philosophers or decision theorists or whoever should come and solve our problem? Or is it an indication that maybe we should look for something which doesn't imply this concept?
I like the second, but I also think there's not, it would be great if physicists were to get involved in the formal epistemology debates. They've got all the mathematical tools needed for those debates, and to a higher degree than a lot of the people involved in these debates would be really great if physicists read some of the literature, interacted with it more. I think that would be great. Maybe the physicists would come up with the better epistemology. I mean, none of this is deep philosophy per se. This is really just playing with numbers, a few little simple axioms. All the mathematics here is simple. I advertised a few theorems. None of them is really very hard to prove. The hardest is that you can get the central limit theorem for finitely additive cases, but even that's not hard.
All right. Well.